and welcome to part 3 of our series on reinforced concrete diaphragms. You'll recall from our first session that we went over the general forces that can be applied and resisted by diaphragm, seismic, wind, and other things. In part 2, we took those horizontal forces and we horizontally allocated them to the vertical elements of our lateral force resistance system. We also obtained internal forces in our diaphragm. Now that we have all of those forces, we're ready to determine how much reinforcement is required at all the different locations where it's necessary. So we're going to start out today by looking at some just basic reinforcement limits for diaphragms, which are the same as any other one or two-way slab. We'll look at how to determine the chord reinforcement, shear reinforcement, the shear transfer reinforcement, and then some specialty reinforcement if you have a collector that's wider than the member that it's framing into. And finally, we'll look into our collector reinforcement. So after this particular part, we'll have the complete design for a diaphragm. And then in part 4, we're going to illustrate all of this with some actual examples, completely worked out examples that show how to determine the forces in the lateral force resisting elements and how to determine the reinforcement. And it'll take all of the stuff that we covered in the first 3 parts and just present it in some pretty practical examples. So that's our plan for today. We're going to take a look at all the different types of reinforcement and how to calculate those. And once again, everything is going to be based on the 2019 edition of ACI 318 and the 2022 edition of ASCE 7. So all the section numbers, etc., that you're going to see today, it's primarily going to be from ACI 318, but all of that is from those particular documents. So we'll start with reinforcement limits. This is going to be very quick. We look into sections 12.6.1 and 12.6.2 in ACI 318. You recall chapter 12 is the basic chapter for diaphragm analysis and design. Going into the higher seismic design categories, that's when we move into chapter 18. But this provision is required for all seismic design categories. We must put at least 0.18% of the gross area of the slab as reinforcement. And that's just your typical shrinkage and temperature reinforcement that's given in section 24.4. Now, generally, we're going to have more than that, but there can be cases, maybe a one-story building that's not heavily loaded, where this might come into play. Not very often, but just let's keep in mind that this is our minimum that we have to apply into our diaphragm. Just another couple things to keep in mind, and we discussed this in our previous sessions, where any reinforcement that we need to resist the specific forces that are resisted by the diaphragm have to be separate than any other reinforcement that's in there, with the exception that we are permitted to use this shrinkage and temperature reinforcement to resist some in-plane forces. Now, there are cases where, depending on the location of where the diaphragm reinforcement has to go, there can be cases where the flexural reinforcement in the slab is not highly loaded. That's when you can take advantage of the bars that are in the diaphragm already in the slab for other purposes than the diaphragm forces. We're not going to illustrate that here today. We're going to do it the more traditional way of providing separate reinforcement for everything. But there can be situations where you can utilize your slab reinforcement as part of your diaphragm reinforcement, provided, and this is a big provided, that the stresses in those bars are very, very small.